In this video, we present the Achilles family of open source data quality tools that have been developed by the Observational Health Data Science in Informatics, or OHDSI community. Achilles is tied to the OMOP Common Data Model, which we use in this course. Briefly, here are the definitions of data quality dimensions, data quality measures, and data quality rules. The Achilles family of tools is an integrated environment that encompasses all three components plus data visualizations. The Observational Health Data Science and Informatics Consortium, pronounced OHDSI, is a loosely organized collaboration involving data partners from around the world. Columbia University hosts the OHDSI Coordinating Center, but there are active semi-autonomous groups that have been formed in Europe and Asia. This community has developed and continues to extend the OMOP Common Data Model and tools that support creating OMOP databases and tools for performing data quality and highly advanced data analytics. The community uses web-based wikis, forums, and webinars to share ideas and ask questions. It is an extremely engaged community of informatics, statistics, and clinical investigators who are committed to performing high-quality data science using observational clinical data. We have used some of the OHDSI tools in other parts of this course. In particular, we used the White Rabbit data profiling tool and the Rabbit in a Hat ETL specification tool to help understand how to transform mimic data into the OMOP Common Data Model. In this video, we illustrate the Achilles, Achilles Heel, and Achilles Web tools for data quality assessment and visualization. OHDSI also has created a terminology browser and a number of data analytics tools. One shortcoming in previous versions of the OHDSI tools was that each tool was developed separately and they did not communicate with each other. Recently, OHDSI tools have been integrated into an overarching combined tool called Atlas that provides seamless access to all of the components that previously were separated. OHDSI has created the Achilles family of data quality tools that work together to provide a comprehensive environment for understanding data sets that conform to the OMOP Common Data Model. Achilles is a purely computational component consisting of a set of R scripts that pre-compute a very large number of data quality measures across all tables and columns in the OMOP CDM and writes those results into a separate OMOP results database. This component can take hours to complete since it is calculating tens of thousands of data quality measures. Achilles Heel uses a set of data quality rules to examine the data quality measures generated by Achilles. Achilles Heel also does not have a user interface. It is a very large R script that writes its findings into the same OMOP results database as Achilles. Finally, Achilles Web brings all of Achilles and Achilles Heel to the surface as an interactive web-based interface that enables browsing and drill downs along with interactive data visualizations to support browsing through the OMOP CDM instance. This is the landing page for the Atlas tool. There is a lot of functionality available down the left navigation bar. In this video, we only focus on the Achilles data quality features. Feel free to explore the other tools, although many of them are geared towards heavy statistical analytic modeling types. All of these tools have wiki pages on the OHDSI.org website, and the code is available for each of them in the OHDSI GitHub site. We access the Achilles web functionality under the Data Sources tab. The demo database does not use the MIMIC dataset that we have licensed for class. Instead, it uses a dataset called SynPuff, which is a synthetic dataset provided by the US government. Because it is a synthetic dataset, not everything in SynPuff makes clinical sense, but it does illustrate how the Achilles tools work and is available from the demo system. We will use the SynPuff 1K dataset in our examples. Feel free to run the tool against the SynPuff 5% dataset. Since the Achilles data quality measures are pre-computed, there is no speed penalty for using the larger 5% dataset. After selecting the SynPuff 1K dataset, we can now select one of many reports or data visualizations available via the Achilles web that is using the results of the Achilles pre-computed data quality measures and the Achilles heel data quality rules. No better place to start than with the first report, the overall dashboard report. The dashboard report is a set of visualizations that provide very high-level views of the data. I have highlighted the sections showing the total number of patients in the data set, the distribution of genders, the age at the time the first observation in the database was recorded, the cumulative distribution of observation records, and the number of patients with continuous observations by month, which is a measure of the amount of time the database has information about a specific individual. We now move to the data density visualization. This display shows the total number of rows, records per person, and concepts per person for each of the 9 tables listed on the right side. This data visualization can highlight any data quality issues associated with periods of missing data within and across tables. We now select one of the single table visualizations. In this case, we are selecting the visualizations associated with the person table. As before, we see a mashup of different visualizations that have been constructed to show essential data quality features that are unique to the person table. We see distributions for year of birth, gender, race, and ethnicity. Feel free to explore the visualizations of other tables, including those that include heat maps for categorical distributions. To look at the results of the data quality rules in Achilles heel, we now select Achilles heel from the bottom of the list of Achilles reports. This is a screenshot of the Achilles heel output. Because it's too small to see on a small screen, the next image zooms to a smaller section. Here, we see that Achilles categorizes issues as a notification versus warning, and provides the rule number and the rule that was violated. At this moment, the rule results are not clickable. They do not take you to the part of the Achilles web visualization that is relevant to this rule. I expect that an OHDSI contributor will enable this feature in the future. As an open source development collaboration, perhaps that contributor could be you. Achilles is a very impressive tool, but it does have some weaknesses, such as mentioned previously. Achilles and Achilles heel are R-based programs, which require local knowledge of the R statistical system. The HEAL rules are very generic rules that apply to every table across the entire OMOP Common Data Model. There currently is no easy method for specifying fitness for use rules tailored to a very narrow use case. Finally, the thresholds used to trigger a notification or warning are not changeable. Since a threshold value may be valid in one use case, but be totally inappropriate for another use case, this is a serious limitation that is being actively investigated by Achilles HEAL developers. As before, since Achilles HEAL is an open source development collaboration, perhaps that contributor who fixes this issue could be you. On the other hand, Achilles tools have very significant strengths. While it is limited to working with the OMOP Common Data Model, it can be attached to OMOP instances in a wide variety of data platforms, including next-generation big data environments such as Hadoop. The rules are segmented into data quality categories, such as rules that examine data model conformance, which are most useful to ETL developers, versus rules focused on data quality measures. Achilles applies a single set of data quality computation methods across the entire common data model. This creates a large set of standardized data quality measures. And as mentioned multiple times, this work is being done using the GitHub collaborative development environment. New data quality rules are being added based on input from the OHDSI community, and new data visualizations are being added to Achilles Web. In summary, OHDSI Achilles is an R-based package that calculates a wide range of data quality measures across the entire OMOP Common Data Model. The Achilles Web component surfaces these results in an interactive interface. The Achilles HEAL component applies a set of generic data quality rules across all tables and columns in the OMOP Common Data Model. And the entire Achilles package is accessible under a single user interface called Atlas.